All right, so today we're going to take a look at lesson 30-2, which is going to be our last lesson for this section before our next test. So we're going to talk about how to look and decide if a function is linear or nonlinear from the table, from the graph, from the equation. We'll give linear descriptions or verbal descriptions of linear functions, and we're going to understand the equation y equals mx plus b. I know we've talked about that before. We've also thrown in some different words for m and b, but how to write the equation of a line. All right, so first of all, one of the things that we are going to use as part of our definition for a linear relationship is there has to be a constant rate of change. Okay, so a linear relationship has to have a constant rate of change. Okay, so remember, rate of change is basically slope. It has to go up 2 over 3, up 2 over 3, up 2 over 3, or up 1, or down 1 over 4, down 1 over 4. Constant means it has to be the same. So that rate of change, or that down 2 over 3, has to be the same every single time. Okay, and we also know that inside the word linear is the word line, so we know that we have to have a line. So I think looking at a graph, it should be pretty easy to determine. If you look at letter A, this is not a line. Okay, so we can say that this is not linear because it's not a line. Okay, so that is a perfectly good explanation. It does not look like a straight line. So if we look at the second part, graph 2, that one looks like a line. So one of the things we have to do is we have to look a little bit closer at that line and find some, what we used to call good points when we were back in class. So if I look at 2, it looks like we've got a pretty good point there. So what's happening is going up 3 and over 2. So it looks like our rate of change or our slope is 3/2. Can I find another point about right here where it goes up 3 again and over 2? And that is going to continue throughout that whole line. So we would say, yes, it's linear. And we can say because it has a constant rate of change. Okay, so that's something that we are going to use quite often to determine if something's linear. We're just going to say, yep, it has a constant rate of change. Okay, so the next example is a table. So we're going to look at this table, and we've got to look. We don't want to graph it. We just want to see if it has a constant rate of change. So is it going up by the same amount every single time? So if I look here to go from 0 to 3.25, it went up 3.25. Okay, now I've got to go from 3.25 to 6.5. And again, probably the easiest way to think about this is money. I'm going from $3.25 to $6.50. So if we want to put a 0 on there at the end, what did we add? We added $3.25, so it went up $3.25. And again, if we look at this one, it went up $3.25. This one, how do I go from $9.75 to $13? I've got to add a quarter, which makes it $10 and $3 more, so that makes it $3.25 as well. And then this one from 13 to 16.25 goes up $3.25. So we can tell that the y values are going up by the same amount. And it's even easier to look at the x values. All of those go up 1. So when we're trying to determine if letter B, the first table, is linear, we would say yes. And again, because it has a constant rate of change. Okay, and again, if you couldn't figure out the math in your head like I was trying to do, you could take these two numbers and you could subtract. Take the second number minus the first number. So if I did 650 minus 325, that would also give me 325, and obviously you can use your calculator for that too. But one of the things you want to make sure is that you take the second number and then subtract the first number in your calculator. So again, taking a look at the next one, this one goes up by $3.50 or 3.5, but the next one just goes up by 3, and then it goes up by 3.5 again, and then it goes up by 3. So right away you can stop and notice that these are all going up by 1, and you can say it's not linear because there is not a constant rate of change. Okay, so that's the big one right there, is that you have to look to see if the rate of change is the same. And remember, rate of change is the change in your y values divided by the change in your x values. All right, so now it's looking at an equation. So if you remember back to when we were doing this last week, our equations always look like y equals the rate of change times x plus the initial value, or that starting point. How much money did you have to start? So it has to be in the form y equals rate of change times x plus initial value. Now remember, that initial value could be 0, so it could be something like y equals 2x, just knowing that there's a plus 0 at the end. And if you take a look at here, that first equation, letter C, it's y equals 3x plus 2. So we could say yes, because it's in the form y equals the rate of change times x plus the initial value. Okay, and then if we look at equation number 2, we can say no, and then because it's not in the form y equals rate of change times x plus the initial value. All right, so again, you're just looking for it to be in the form y equals rate of change times x plus the initial value. This one had a squared on it, so that is not even close. All right, so taking a look at the next page, it says sketch a graph of the functions described below. So they're going to give us a situation, and you've got to graph that situation. So it says at Sunday King, the price of a sundae is a function of its weight. All right, so if we look at x and y values and we're trying to figure out what it is, the y value is your cost of your sundae, and then the x value is the weight. So it doesn't say any numbers, so we don't have any actual numbers, but we could make some up. Okay, so if you think about it, if you buy a sundae that weighs 0 ounces, okay, you wouldn't have any ice cream or sprinkles or whatever you like in your sundae, so that means you didn't buy anything. So that cost is going to be down at 0, 0. Okay, notice it says the king charges the same amount for each ounce. So say he charged 50 cents an ounce. So if I had 1 ounce, it would be 50 cents. 2 ounces would be $1. 3 ounces would be $1.50. And if you look at that rate of change, it's going up 50 cents, up 50 cents, up 50 cents. So this would be up 50 cents, and these were going up 1 ounce. Okay, so if you think about it, it has a rate of change that is 50 cents over $1. So we know that that would be a nice linear situation. So if I had 1, this would be 50 cents. If I had 2, this would be $1. So it would form a nice straight line. Okay, so the next one says, the cost to join an online gaming site is $12. The player is then charged $1.75 for each hour. Okay, so again, our y value is our cost, and our x value is going to be the number of hours that the person played video games. Well, it has an initial cost, so it says the cost to join is $12. So even if you don't play any games, and we've done this before, your cost is $12. Okay, now it says it's $1.75 per hour. So if you play 1 hour, you're going to pay an extra $1.75. So you're going to pay a total of $13.75. If you play 2 hours, you've got to add another $1.75, so that's going to be $15.25. If you play 3 hours, you've got to add another $1.75. That gets us to $17. Okay, so again, this does have a constant rate of change because every time we had to add $1.75, and each of the hours was going up by 1. So again, we could number these if we wanted to. We could say we'll go 12 is right here, and then we'll say maybe this is $15 and $18, and then we'll do 1 hour, 2 hours, 3 hours down at the bottom. So the one thing we have to be careful with here is our y-intercept is not at 0, 0, or our initial value. Our initial value is up at 12. So it's going to start higher this time at $12. And then if you play 1 hour, it's about $13.75. 2 hours would be just a little bit above $15, and 3 hours would be $17. So again, because it has a constant rate of change, that graph is linear. All right, so the next one gives us an equation. And remember, it has to be in the form y equals rate of change times x plus the initial value. So there's no initial value here, so that's got to be a 0. Okay, so we're going to 0, 0. And remember, our rate of change is 3. We always want rate of change to be a fraction, 3 over 1. So it's going to go up 3 and over 1, because remember, it's the change in y over change in x. So I have to go up 3 and over 1. I got to go up 3 more to 6, and then over 1 to 2, up 3 more over 1, and that's going to be a nice straight line. All right, and then the last one says your cell phone bill is a flat monthly rate of $50. So it doesn't matter how many minutes you use, how many text messages you send, how much data you've used, Snapchatting or making fun TikToks. It says your monthly rate is always $50. So it doesn't matter if, how much you do. So each month it's going to be $50. So if this is $50, if I go 1 month, it's $50. 2 months, it's still $50. Or if it's 1 phone call, 2 phone calls, 3 minutes on your phone or 3 megabytes of data. So it's going to stay the same. It's going to be a flat line or a horizontal line where that rate is $50. It's not changing. All right, so let's keep going with that. It says sketch a graph for the function, or for the sketch a graph for the functions described in 3 and 4. It says a fighter jet appears to be descending at a steady rate. So descend means to go down. So when you're on a plane, it's landing at a steady rate. Okay, obviously, I think if you were on an airplane, you wouldn't want it to speed up as it was descending or going down. So it says the altitude of the jet. So that means our y value is the altitude or the height of the jet, and is a function of time. So that means our x value is time. So if your jet is in the air, it's somewhere up here. And again, we don't necessarily need numbers, but if it's flying or it's descending at a steady rate, it's going to go, down 3 over 2, down 3 over 2, down 3 over 2. So that's going to be a nice straight line, and eventually it will land safely on the ground. Okay, the next one says the value of y decreases as the value of x increases. So we know this is x and this is y. So our x is going down as our y is going up. So again, we can just pick some random starting point. The x is going to go down, and it doesn't say how many, and then the x's are going to go up. So our y values go down, our x values go up. Our y values go down, our x values go up. So that graph would look like that as well. All right, so then the next one says sketch a pair of graphs, one that's linear and one that's nonlinear. Okay, so that shouldn't be too bad. Let me set it up real quick. So we've got to do 2 graphs, one of which is nonlinear and one of which is linear. So the linear one should be easy. You can draw whatever line you wish. You can make it start up here. You can make it start at 0, 0. It can start here and go down. Any of those 3 purple lines that I just drew would be an example of a linear function. Okay, nonlinear would be something that's curved. So, you could draw kind of a wave like that. You could draw something that goes up and down and up and down. It doesn't matter as long as it's not a straight line. All right, so your homework for today is going to be to do the lesson practice on page 30 or on page 420, and you are going to do problems 6 through 10, all of them. So our homework is on page 420, and you are doing 6 through 10. Okay, so go ahead and get that taken care of and submit it online on Schoology. And then on Thursday, you're going to get a review sheet. There won't be a video for Thursday. Once you submit that worksheet, I will grade it and get it back to you. And then there'll be a day 2 to the review as well. So you're only going to do half of the review on Thursday. Have a great day. Thanks.